Hello viewers, welcome to my channel. I'm Hasham Ali Khan. Last video I have completed one problem on simplex method. So we have different types of problems in simplex method like maximization problem, minimization problem, mixed constraints and duality. So the procedure is slightly different in every type of problems. So if you want the perfect knowledge, watch all the videos from beginning till end. Then only you can be able to get the complete command. And while watching the video, always maintain a running notes, because whatever points I'm explaining, that points you have to note it down. And also it needs a lot of practice. Simply watching the video is not at all sufficient. Practice is required. So watch the video not once, twice, thrice. And if you have not watched the earlier videos, I suggest you go to the playlist of my channel, select the subject Operation Research, select the videos of linear programming, be perfect about the concept. Now, before starting the second problem, I expect my viewers to have a printout of the problems which I have given in the link under my description. Take the screenshot of the points, then I'll explain. Come on, see the second problem. The ABC manufacturing company can make two products A and B. Each of the product requires time on cutting machine and finishing machine. The products are two, A and B. For making these products, we require two resources. Those resources are machine, cutting machine and finishing. Relevant data, products A and B. Cutting hours per unit on A, 2 hours, and on B, 1 hour. And finishing hours per unit on A, 3 hours on product A and 3 hours on product B per unit. Profit per unit for A is 6 rupees and 4 rupees for product B. Maximum sale unit per week, 200 units. That means the number of cutting hours available per week is 390 and the number of finishing hours available per week is 810. How much should be produced of each product in order to achieve maximum profit for the company? The problem is maximization problem because profit is to be maximized. How many units of A and how many units of B should be produced? We have three constraints. The first constraint is the cutting hours are limited to 390 hours. We don't have more than 390 hours. So either we can make use 390 or less than 390, but we don't have more than 390. Similarly, for finishing machine, we have 810 hours. We don't have more than 810. We can make use either 810 or less. So less than and equal to. And third constraint is maximum sales units per week for B. For A product, there is no maximum sale. Any limit we can sell. But for B product, there is maximum sales in units, 200 units. That means we cannot be able to sell more than 200 units of B product. That is also a limitation. We can sell either 200 units or less, but we can't sell more than 200 units. So three constraints, right? And we have to find out how many units of A and B. First of all, we suppose let x1 is equal to number of units of A and x2 is the number of units of B to be produced and sold to earn maximum profit. First of all, the given data should be written in a mathematical model in an objective function and constraints functions. So the problem can be formulated in appropriate objective function. The objective is to maximize the profit. What is the profit per unit of A? 6 rupees and 4 rupees. So maximize Z is equal to 6x1. x1 is the number of units of product P1. Not P1, product A, sorry. Product A. x1 is the number of units of product A and x2 is the number of units of product B to be produced and sold. So profit function is 6x1 plus 4x2. That is the objective function. Subject to constraint. How many hours, cutting hours are required for producing A product? 2 hours. So 2x1. x1 is the number of units of A So 2x1. And how many cutting hours for B? 1 hour. So 1x2 is x2. Less than and equal to. What is the maximum time available on cutting machine? 390. So less than or equal to 390. Similarly, for finishing machine, how many hours are required for product A? 3 hours. And for product B, 3 hours. So 3x1 plus 3x2. Less than or equal to. Maximum time available in finishing hours, 6, 8, 10. 8, 10. And third constant is the limit on sales of B product. B means x2. So how many units we can be able to sell? Maximum 200. Which product? B product. So B is nothing but x2. So x2 is less than or equal to 200. We can't sell more than 200 units of B product, x2. And non-negativity function says x1 and x2 should be always greater than equal to 0. We cannot make negative production. Production will be 0 or positive. So x1 and x2 greater than equal to 0. Where x1, x2. To convert the inequalities into equation, we have to introduce slack variable. Slack variable will be added whenever we have less than equal to sign. Remember that point. So how many constraints do we have? 3 constraints. 1, 2, 3. So we need 3 slack variable S1, S2, S3. So we have to add S1, S2, S3 to convert the inequalities into equations. So standard format will be maximize Z is equal to 6x1 plus 4x2 plus 0 into S1 plus 0 into S2 plus 0 into S3. 0 is the coefficient of S1, S2 and S3. Subject to constraint. The first constraint 2x1 plus x2 plus S1 is equal to 390. Similarly 3x1 plus 3x2 plus S2 is equal to 810. Third x2 plus S3 is equal to 200. And non-negativity constraint says x1, x2, s1, s2, s3 greater than or equal to 0. That's it. Now, initial solution can be obtained by taking the decision variables as 0. Decision variables are x1 and x2. So x1 is equal to 0, x2 is equal to 0. When we take x1 0 and x2 0, what will happen? S1 will become 390. Here S2 will become 810 and S3 will become 200. So S1 390, S2 810 and S3 200. That's all. Now we have to make the first simplex table. The first simplex table is very simple because we don't need any formula. So already in the previous video I told you the format of this simplex table. CJ stands for the coefficient of objective function. This is the objective function. The coefficient of x1 is 6. The coefficient of x2 is 4. The coefficient of s1 is 0, s2 0, s3 0. The CJ values are there in the row as well as in the columns. So in columns 0, 0, 0. S1, S2, S3. S1 value is 390, S2 is 810, S3 is 200. That's all. Now in this body of this table, we have to take the coefficient of constraints. The first constraint is 2x1. So in x1 we will take 2. Then x2 is 1. Then s1 is 1. Then s2, s3 will take zeros. Next one is 3x1, 3x2. So this is 3, this is 3. And s2 is 1. This is s2, 1. Here 0 and here also 0. Now third, x2 is equal to 1. This is x2, 1. Then s3, 1. This is s3, 1. All other values are zeros. That's all. Table completed. Now zj we have to find out. Multiply the cj with the variable. 0 into 390, 0. 0 into 810, 0. 0 into 200, 0. When anything is multiplied by 0, you will get 0. So ultimately 0. Second column. 0 into 2 plus 0 into 3 plus 0 into 0, 0. Anything when multiplied by 0, it will become all zeros. Now Cj minus Zj. Cj is there in the first row and Zj last row. So 6 minus 0 6. 4 minus 0, 4. 0 minus 0, 0, 0, 0. Now after this, here below the table you should write down the optimality test. The optimality test says all the index row element, this is the index row. This Cj minus Zj is called index row. All the index row elements should be zeros and negatives. Then we reach the optimum solution. If any positive value is there, we have not reached the optimum. We have to go another table. But here, if there is positive, select the highest positive. Write down all these notes because there is no space. That's why I have not written. You write down. Optimality test says if the problem is maximization problem. Problem is maximization problem. The index row elements should be zeros and negative. Then we reach the optimum solution. If there is positive, we have not reached the optimum solution. Select the highest positive. The highest positive is 6. The highest positive element is 6. Now for which element it is 6? X1. So in the next table, X1 will enter. And these are called intersectional elements. What we call intersectional elements. Now which variable to be departed? It depends on minimum ratio. Minimum ratio is solution value divided by intersectional element. What is the solution value? 390. So 390 divided by intersectional element 2. That is equal to 195. Similarly, 810 divided by 3. 810 divided by 3. It is 270, I think. 810 divided by 3. 270, yes, it is 270. And lastly, 200 divided by 0 is undefined. When anything is divided by 0, it will be undefined, infinity. So here 0 is there, 200 by 0, infinity. So these two values, whichever is the lower value, minimum value, 195 is minimum. For which value it is 195? S1. So S1 will depart. In the next table, we remove S1, depart S1, and in place of S1, we enter X1. So here, table number 2, simplex table 2. X1 enters and S1 departs. That's all. First table completed. Now we are coming to the second table. We have to make improvement in each table. Now again, in place of S1, I am taking X1. The remaining S2 and S3 are same. This is S2, this is S3. Now coefficient of X1 is 6 here. S1 0, S2 0, S3 0. Now we need the values of the entering variable. The values of entering variable is equal to values of departing variable divided by intersectional element. Intersectional element. Values of departing variable. Which is the departing variable? S1. And which is the entering variable? X1. So we have to divide. What are the departing variables? 390. See here. Then 211. 211. 0, 0. These are the values of the departing variable. Divided by intersectional element is 2. So divided by 2. 390 divided by 2, it comes to 195. 2 divided by 2, 1. 1 divided by 2, 1 by 2. 1 divided by 2, 1 by 2. 0 by 2 is 0 and 0. Don't write 1 by 2 is equal to 0.5. Don't take it in fraction. It will require more time if you do all these things in fraction, in points, decimals. Write it down 1 by 2. That's it. So these are the values of X1. So 195, then 1, 1 by 2, then again 1 by 2, then 0 and 0. That's all. These are the values of the entering variable. Now we need the variable of S2 and S3 in the previous problem also. Same procedure, same rules we have to apply in every time. So now value of S3, value of S2 is equal to old values of S2, old values of S2 minus intersectional element into values of entering row. This is the formula we apply to calculate the new values of S2. Old values of S2 are 810, then 3, 3. 810, 3, 3, 0, 1, 0. 0, 1, 0 minus. Then what is the intersectional element of this S2? 3. So 3 into values of the entering variable. Entering variable are 195, then 1, 1 by 2, 1 by 2, 1 by 2, 1 by 2, last one 0, 0. That's it. Now we have to find out what are the values of S2. So 195 into 3, 195 into 3 is equal to 585. 810 minus 585, 585, 810 means 225. Here 3 minus 3, 0. 3 minus 3 into 1 by 2. That means 3 minus 3 by 2. Right? If you take LCM, 3 2s are 6, minus 2 2 get cancelled 3. So 3 by 2 will remain. Then 0 minus 3 by 2 is minus 3 by 2. 1 minus 0, 1. 0 minus 0 is 0. See here, 3 minus 3 by 2. 3 into 1 by 2 is 3 by 2. So 3 minus 3 by 2, if I take LCM, it will be 2. So 2 3s are 6, 2 2 will get cancelled, 1. 3 by 2, correct. So these are the values of S2. So here S2 values 225, then 0, 3 by 2, minus 3 by 2, 1 and 0. That's it. Over. Now we need the values of S3. To find out the value of S3, same procedure we have to follow. Values of S3. Old values of S3 into old values of S3 minus intersectional element. Now see here, old values of S3 are 200, 0, 1, 200, 0, 1, then 0, 0, 1, 0, 0, 1, 200, 0, 1, 0, 0, 1 minus intersectional element. What is the intersectional element of S3? 0 into values of entering variable. What are the values of entering variable? 195, 1, 195, 1, then half, half, 1 by 2, 1 by 2, 0 and 0. These are the values of the entering variable. Now anything multiplied by 0 will become 0. So in all these bracket it will become 0. So same values will remain, that is 200, 0, 1, 0, 0 and 1. That's it. These are the values of S3. So I am writing it down here, 200, 0, 1, 0, 0, 1. That's it. We have calculated all the values. Now ZJ value. Multiply 6 into 195 plus 0 into 225 plus 0 into 200. When you multiply 0, it will become 0. So only 6 into 195. So 195 into 6, it will become 1170. 1170. Here 6 into 1 is 6. 0 into 0 and 0 into 0 is 0. So here it will become 6. So here 6 into 1 by 2, 2 3s are 6, 3 times. Because here 0, this will also become 0. 6 into half is again 3. This will become 0, this will become 0. 6 into 0 is 0, 0 into 1 is 0, 0 into 1 is 0. Here 6 0, then 0, then 0. That's it. Now, we have to find out the Cj minus Zj, that is the index row elements. If index row elements are zeros and negatives, we reach the optimum. If any positive value appears, it is not optimum, we have to go one more table. Now 6 minus 6, 0, 4 minus 3, 1, 0 minus 3 is minus 3, 0, 0. So again we got one positive value 1. So this is not optimum. One more table we have to make, same procedure, right? So here, this is the entering variable. X2 is the entering variable in the next iteration. So these are the intersectional elements, right? Now which is the departing variable depends on minimum ratio. Solution value divided by intersectional element. Solution value is 195. Divided by 1 by 2. Divided by 1 by 2. If we multiply, it will become 2 by 1. (195) divided by 1 by 2. When we divide 1 by 2, if we multiply, it will become 2 by 1. So easily we can take 195 into 2 by 1, 390. Similarly, 225 divided by 3 by 2. So if we multiply, it will become 2 by 3. So 225 into 2 by 3. 225 into 2. 225 into 2 divided by 3. It will become 150. Here 200 divided by 1 is equal to 200. Now in these three values, whichever is minimum, first one 390, second 150, third 200. So 150 is minimum. So for which variable 150? S2. So S2 will depart. In the next table, X2 will enter and S2 will depart. So here I am writing X2 enters and S2 departs. In place of S2, I am going to write X2. The first X1 remains same. Second, in place of S2, I am taking X2. Third, S3, same. Now coefficient for X1 is 6, X2 is 4 and S3 is 0. Again same procedure. Values of entering variable. Which is the entering variable here? X2 is the entering variable. X2. Values of departing variable. Departing variable is S2. Divided by intersectional element. So now I am going to calculate the values of the entering variable. Values of the entering variable. Departing variable is S2. The values are 225, then 0, then 3 by 2, minus 3 by 2, 1 0, 1 0. Divided by intersectional element. The intersectional element of S2 is 3 by 2. So divided by 3 by 2. Divided by 3 by 2. So 225 divided by 3 by 2. This can be written as 225 into 2 by 3. So 225 into 2 by 3. Into 2 divided by 3. It comes to 150. Similarly, 0 divided by 3 by 2 is 0. 3 by 2 divided by 3 by 2 is 1. Minus 3 by 2 divided by 3 by 2 is minus 1. 1 divided by 3 by 2 is 2 by 3. 1 divided by 3 by 2, it will become 2 by 3. Then 0 divided by 3 by 2 is 0. That's all. We got the values of the entering variable. Entering variable is what? X2. So we got X2 values as 150, 0, 1, minus 1, 2 by 3, and last one is 0. That's it. So we got the values of the entering variable. Now we need the values of x1. x1 values. The old values of x1 we will take. Old values of x1 minus intersectional element into values of the entering variable. These calculations only will test your patience, will test your mathematical ability, and only by practice you can be able to get the command. Now, old values of x1, the old values of x1 are 195, 1 by 2, again 1 by 2, 0, 0, minus. Then intersectional element of x1 is 1 by 2. 1 by 2 into 1 by 2 into values of the entering variable values are 150, then 0, 1 minus 1, 1 minus 1, 2 by 3, 0, 2 by 3 and 0. That's all. These are the values of x1. So 150 into 1 by 2, it will become 75. So 195 minus 75 is 120. 195 minus 75 is 120, right? 1 minus 0, half into 0 will be 0. So 1 minus 0 is 1. 1 by 2 minus 1 by 2 is 0. The 1 by 2 minus into minus will become plus 1 by 2. So 1 by 2 plus 1 by 2, 1. 0 minus, this 2 will get cancelled. So 1 by 3, so minus 1 by 3. Here 0 minus 0 is 0. That's it. We got the values of x1, that is 120, then 10, then 1, minus 1 by 3, last one is 0. That's it. So we got the values of x1. Now lastly we need the values of S3. The same procedure, values of S3. Old values of S3 minus intersectional element into values of the entering row. So old values, again we have to make the calculations. See here, old values of S3. Here old values of S3, 200, 0, 1, 0, 0, 1, 0, 0, 1, minus intersectional element of S3 is 1, 1 into values of the entering variable 150, 150, 0, 1, minus 1, 2 by 3, then lastly 0 is equal to 1 into 150 is 150. 200 minus 150 is 50. Then 0 minus 0 is 0. 1 minus 1 is 0. 0 minus into minus will become plus. So 0 plus 1 is plus 1. 0 minus 1 into 2 by 3 is 2 by 3. So minus 2 by 3. Then 1 minus 0 is 1. That's it. Now you take these values, S3 values, 50, 0, 0, 1, minus 2 by 3, then 1. That's it. We got all the values. Now we have to calculate the values of Zj. So multiply the Cj value with the variable. So 6 into 120. It's 6 into 120. It will be 720. 720 and 4 into 150. 4 into 150 is 600. So 720 plus 600 it will become 1320. 6 into 120 plus 4 into 150. 0 into 50 will become 0. So these two, if we add up, 1320. Here comes 1320. Similarly, 6 into 1 is 6. 4 into 0, 0. 0 into 0 is 0. So 6. Here 6 into 0 is 0. 4 into 1 is 4. 0 into 0 is 0. So 4 ones are 4. Here 6 into 1 is 6. Then 4 into minus 1 is minus 4. Then 0 into 0 is 0. 6 minus 4 is 2. Here 6 into 1 by 3 is minus 6 by 3. Minus 6 by 3. 6 into minus 1 by 3. Plus 4 into 2 by 3. 4 2 is 8 by 3. Plus 8 by 3. So if you take the LCM 3, minus 6 plus 8. So 8 minus 6 is 2. 2 by 3. So here remains 2 by 3. 2 by 3. Last one, 6 into 0, 0. 4 into 0 is 0. 0 into 1 is 0. That's all. So we have calculated all the Zj values. Now Cj minus Zj. Final. This is the index row elements. So 6 minus 6, 0. 4 minus 4, 0. 0 minus 2 is minus 2. 0 minus 2 by 3 is minus 2 by 3. And 0 minus 0, 0. That's it. So optimality test says all the index row elements should be zeros and negatives. And we got index row element is 0, 0, minus 2 by 3, 0. All are zeros and negative. We reach the optimum solution. Now, there is no space, but I'm explaining you note it down. You write it down. Since all the index row elements are zeros and negatives, so we reach the optimum solution. The optimum solution is x1 is equal to 120, x2 is equal to 150, and the maximum z value is 1320. This is the solution. This is the answer. So in order to maximize the profit, 120 units of product A, 150 units of product B, because x1 is the number of units of product A. Here you have written x1 number of units of product A, x2 number of units of product B. So 120 units of A, 150 units of B must be produced in order to get a maximum profit of rupees 1320. That is the final answer. So 2 problems I have completed on this simplex table. It's time consuming, but you can reduce the time by practice. Only one method is the practice. The same problem you have to try it again. Watch the video again and again. Then only you can be able to get the complete concept. And one more thing, your calculations should be fast. Accurate and fast calculation is the prerequisite of doing the problem on simplex method. So inshallah we'll continue the next problem in the next video.